Okay, so today, big day. You don't see it that way, but I do. So you had your big day at classical conversations where you got together with everybody else. Today it's time to get serious. You got all this work for classical conversations you have to do, but today is like a really serious day for geometry too. So give me some time. Okay, it's going to be a kind of short video, but it's going to really take you some time to do the homework. So I'm hoping to make the video good enough so that you don't have to take too much time for the homework, but it may take you more than one day. So just be warned. Remember, tomorrow you've got to review for your test. It's going to be on Monday, and there is a review. So there's that. Okay, so today we're going to go over perpendicular lines. That's our topic. This is the symbol for perpendicular. Once again, we always try to stick with symbols because it makes it shorter to write stuff. So perpendicular lines form 90-degree angles. That's one of the first ones that you have that's a shortcut. Now today, I'm going to be kind and tell you what that's a shortcut for. In your book on page 28, theorem 1.10 says, if two lines are perpendicular, then the pairs of adjacent angles they form are congruent. So I shortcutted that down to this much smaller phrase, by the way. They got two lines. I got less than one with symbols to make it faster. What they're saying, though, is when you have two lines that are perpendicular, the symbol you use to say that they are perpendicular is actually the right angle symbol, which we know means that it's 90 degrees. So that's why not only is this 90 degrees, but all of these are 90 degrees. So that takes care of some of the corollaries on the next page too. It says if two lines are perpendicular, then all four angles are congruent, because we know all 90-degree angles are congruent. So I don't need to write that corollary because it's summed up in that. They form 90-degree angles, and you know 90-degree angles are all congruent. The next one says if two lines are perpendicular, then all four angles they form are right angles. We know 90-degree angles are right angles, so we're covered. All three of those can be summed up in that one statement. A lot less to write. Just turning the page. The next theorem says if there is given any point in a line and plane, then there is exactly one, blah, blah, blah. We'll get to that in a second. Moving on. A perpendicular bisector, because this is what I want to talk about next. A perpendicular bisector not only bisects, which means it goes through the midpoint, and by the way, this is a definition, not a postulate. That's why we're doing it next. Not only bisects, which means it goes through the midpoint of that line, but it also forms 90-degree angles because it's perpendicular. So just because I have something where this is my midpoint of these two, I could have any line go through it that bisects it. This line bisects it, but it is not perpendicular to it, so we can't call it a perpendicular bisector. We can say that it bisects it, which means it goes through the midpoint, but we cannot say that it is perpendicular to it. That's how you know that's the midpoint. I'll go ahead and mark that part. So if it's perpendicular to it, it also has to have that 90-degree angle. That's how we can say that CD, and check this out, doesn't mean that this one is congruent. But all I'm going to say is that line CD, and make sure I write it as a line, is a perpendicular bisector of line AB. Line AB is the one that gets bisected. CD doesn't mean anything about CD. We don't know that that's a bisector. They didn't say that. We can't assume that. But we do know that CD is the perpendicular bisector of AB. So AB is the one that's split up in half. Now let's get on to theorem 1.12, like that's what we should call it or something. So it says, if there is any given point in a line in a plane, on a line in a plane, then there is exactly one line in that plane perpendicular to the given line at the given point. That's a whole heck of a lot of words, and I know you don't have an idea about what it's saying. So give me a second. In the same plane, there can be only one line that is a perpendicular bisector. That's what it's saying. So if we're talking about the plane of the board, okay, because that's easier for me to draw. This is my line that they're giving you. I'm going to call it AB because I like to stick with like things. It says that the same plane, so I have to make sure I stick with my plane of the board, can't be coming out from it. There can only be one line that is a perpendicular bisector. That's because there is only one point that can be the midpoint. And since there's only one point that can be the midpoint, then there's only one line that can be a perpendicular bisector. So DE is my perpendicular bisector of AB. Now, this whole thing about this point is that the point that they're talking about that has to be in the same plane is like point D. It has to be in the same plane. I couldn't have a point out here that's a perpendicular out here that's a perpendicular bisector. That's perpendicular to it, that's true. And it is a bisector, but this is not in the same plane as the board. And since that this is not, I'm going to put something you can see, this is not in the same plane as the board. It is perpendicular to the board. So I know it's perpendicular, and I know it's a bisector, but it's not in the same plane. It has to be in the same plane, and there's only one that can be in the same plane and be in a perpendicular bisector. Okay, that's theorem 12. There's really no other way to shortcut it than saying that. Corollary, if there is given any segment in a plane, then in that plane there's exactly one line that is a perpendicular bisector of that segment. That's the shortcut version. That works for both. Theorem 1.13, if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. In other words, if I have this angle and this angle, angle ABD and angle DBC, if they happen to be complementary, now if they happen to be perpendicular, if they happen to form a perpendicular, then you know that these two angles are going to be complementary, or they're going to add up to 90 degrees by angle addition. All that is telling you is it's attaching the name complementary to these two angles, because you could already see that they added up to 90 degrees, but we had to attach that they were complementary. They happen to be adjacent and complementary. And then the last one says, if there is a point not on a line, then there is exactly one perpendicular that is given to that line through the given point. We did this in algebra. we didn't word it this way. But there's my point out there. When we were graphing, I would give you the slope of this line, and I would tell you to find the equation of the slope of the line, or the equation of the line that goes through this line, through that point that is perpendicular to that line. What they're saying is that there is only one line that is perpendicular through that point and that line. There only exists one of those. Same thing as the perpendicular bisector thing, only it doesn't have to be a bisector. They're not giving you the bisector, but through one point, there is only one line that'll be perpendicular to this line. Okay? So I have explained the corollaries, the postulates, the theorems, in a hope that you can go now and write those. I am done with this section, except I want to go over a couple of problems in the classroom exercise. So, pardon me while I do some writing. Okay, so this is the sum up of all of section 1.6. These come from the class, don't write this down. I'm getting ready to tell you. These come from the class exercises on page 31, and you can just look in there instead of drawing all this out and then write the reasons down in your notes, because you can tell that it was on page 31, and when you go back to look at your notes, you can just open up your book to page 31 and not have to write all this mess down like I just did, so that I could point at it for you. That's why I have to be able to pause so I can draw stuff and it doesn't take up a ton of your time. Okay, so we're going to go through these kind of quickly, and it'll make for a short video today, and I'll make it very good. Okay, if M is perpendicular to K, they're talking about line M here and line K there. It says if they're perpendicular, then these angles are all right angles. How do we know that? What's the postulate we just went over that tells us that? Well, it's that perpendicular lines form right angles. That's simple. Perpendicular lines form right angles. That's our reasoning. It doesn't have to get any harder than that. Number 3 says if AP, that's this little bit right here, is congruent to PB, that's that little bit right there. It doesn't look like it here, but if it were, and if K and M were perpendicular, then M is the perpendicular bisector of K. It's not really the perpendicular bisector of K, it's really the perpendicular bisector of AB, but we're going to let that go right now. The reason that is because the definition of perpendicular bisector. We said when we defined perpendicular bisector that it cuts this in half, which means it would make two congruent parts, and it was perpendicular lines that did that. Number 4, if M and K are perpendicular, then angles 3, 4, 5, and 6 are all congruent. How do we know that? Perpendicular lines form right angles, and right angles are congruent. You don't have to use the same statement. You can have more than one statement to get to this. That's okay. Number 5, if the measure of angle 1 is congruent to the measure of angle 2, then K is perpendicular to L. Well, we know by the definition of linear pair that they have to add up to 180, and if they're congruent, then they each have to be 90. Let me use a symbol. So if they're congruent, they are equal measures by definition of congruency, and therefore, and must be 90 degrees. See, I don't need all those corollaries written out. I just need to be able to follow the trail to what all those corollaries said. For number 6, if M is perpendicular to K, then angle 3 is congruent to angle 4. Well, that reason is because perpendicular lines that's why you don't want to write it out. It's too long. Perpendicular lines form right angles. And right angles are congruent because they're all equal to 90 degrees. So you may have had slightly different statements from me, but you may have gotten to the same conclusion in the end, and that's what's important, that you get to the same conclusion in the end. Okay, so the homework and classwork for this section are not out of the book. The homework and classwork for this section are not solely about this section. It's actually about everything we've done. It is not what's this postulate, what's this theorem, what's this definition. It's actually doing problems like we've been doing the past couple of sections. But it is incorporating all the knowledge that you've gained from this chapter to try to figure out some answers. Now, when I go over, because your classwork is a worksheet, when I do that one problem, and your mom has a copy of me doing that one problem too, when I did that one problem, I wrote down everything, how we knew everything, what kind of theorems we were using to justify that. That is not what I'm asking you to do. I just want the short answer, just the little thing that goes in the box. I don't need to see a proof for it, but I wanted to provide you a proof for it so you kind of understand how we were doing proofs. The specific proof that I provide for you is kind of like a paragraph proof, where one thing leads to another, leads to another, leads to another, and it's all written in paragraph form. That's not the kind of proofs that we'll be writing in here, but it's the kind that would make the most sense to you right now. The kind that we're going to be writing in here are double-sided proofs, where you have something given and you work down to what you want to find out on one side, and on the other side you have to give all the reasons for those proofs. So we'll get to those proofs and more about doing those proofs in chapter 2. So I'm not really worried that you know the reasons or that you call it the right thing. What I'm really worried about is, are you using the information that you've gleaned out of chapter 1 in order to get the answers they're asking for on those problems. Now, you don't have to do the whole worksheet. I've gone ahead and marked out problems 2 and problems 8 for you. I do problem 1 because that's your classwork problem, that problem number 1. So I do that, and there's the answer to that in your mom's stuff. But problems 3, 4, 5, and 7 are what you need to do for homework. And it may take you some time. It's okay if you have to think about it and you come back to it later and you think about it again, you put it down, you get some idea 3 hours later. Oh, I bet that's how you do it. And then you go check it out and da-da, you've done one problem. It's okay if it takes some time, if you have to think about it a while, because you've had a lot of information thrown at you in just one chapter. And sorry, but the following chapters are going to be full of a lot of information too, and you have to remember it all. So don't be worried if it takes you a little bit of time to do it. Don't be worried if you can't even finish it tonight. It's the kind of thing where I want you to think about it over some time. So it's okay if you're not done with it until, I don't know, Saturday. But go ahead and start it today. Don't just look at it and read it, and if it doesn't come to you, put it up. Spend some time thinking about it. Go through those steps we talked about. List out all the things that you know about the picture right away, and then in your mind, and then which of those things is going to help you get to the answer? Because that's what I'm really after, is what the answer is. But you've got to go through those steps and practice those steps some, so that you can kind of get faster at this, which will make you feel much better, because once you get faster, it seems like it's easier. So what you need to do is do the worksheet, and then on tomorrow, whether you want to or not, there is a review. And I'll go ahead and tell you, the review is the test, the chapter test in the book, located on page, ta-da, 42 in your book is the chapter test. That is the best thing for you to study. The answers to the chapter test are probably not in the back of the book, because that seems like it would be counterproductive if they're going to call it the test. Give me 1 second and I'll tell you if they are not. Chapter, nope, they're not. Yay for me. That means that I have to make a photocopy of this page and include that so that you can have the answers as they see them, and I'll make sure they are reflected with what I need you to know, as opposed to what the book would like to put, because the book really does like to do theorem 1 and corollary whatever, and that's not what we're going to do. So yeah, I'm done. Yay! We finished chapter 1. Okay, you in chapter 2.